Alright, I'm going to finish off section 14.3 by verifying some identities. Verifying is different than simplifying, so one thing you might want to note: when you simplified, it didn't equal anything. So for example, take this away. Just given this expression, you were asked to simplify it, so to get it down, as small as you possibly can. When you're asked to verify something, then you're going to show that this quantity is equal to this quantity. So one thing you're going to want to jot down when you verify: you're only going to work with one side. Okay, so I'm going to write that down. Work with one side, and one side only. So for example, if I decided I'm going to work with this side, I'm going to simplify this as much as I can until I get it to equal sine squared of x. So I'm not going to change the right hand side, only the left hand side. Or vice versa, I could work with the right hand side and change it up until it equaled the left hand side. I'm sure you're with me that probably would be easier to work with the left hand side and simplify it to get it down to sine squared of x. So that's what I will do. So starting with the numerator here, cosine squared of negative x, anytime you see those negative angles, I would take a peek at your negative identities. I'm going to blow this up for just a second. So remind yourself that the cosine of a negative theta is equal to the cosine of positive theta. Okay, and you don't have to have the identities memorized, so just kind of making you think about that. So cosine of negative theta equals cosine of positive theta. So cosine squared of a negative x is going to equal cosine squared of a positive x. And then cotangent, again, anytime you have a squared, you might want to use the Pythagorean identities, or you can get things in terms of sine and cosine. This one is fairly small and easy to work with, so I'm going to take the cotangent and just do the cotangent rule over here. I'll circle it. That says cosine over sine. Well, if cotangent is cosine over sine, cotangent squared is cosine squared over sine squared. Okay, so I'm going to divide that by cosine squared divided by sine squared. Okay, then I'm going to take the numerator and multiply by the reciprocal. So the numerator is cosine squared x, and I'm going to multiply by the reciprocal of the denominator. So I'm going to flip that and get sine squared x over cosine squared x. This is technically over 1, so the cosine squares, of course, cancel out, and I'm left with sine squared x, and that's what I wanted to get to. So that equals sine squared x. So I just proved that the left-hand side equals the right-hand side. And that is how you verify something. Alright, so we're going to verify again, and this one says secant theta times 1 over cosine theta minus tangent theta times cotangent theta equals 1 minus cosine squared theta divided by 1 minus sine squared theta. Again, you can pick either side. It's just the luck of the draw. I'm going to work with the left-hand side. I usually just pick the side that's bigger, has more going on, and I'm going to condense it down in hopes to getting to it looking like the right-hand side. So I see lots of inverse functions or reciprocal functions here, so I'm going to change secant to 1 over cosine first. So that's 1 over cosine theta times 1 over cosine theta. And of course that's 1 over cosine squared theta. And then tangent theta, is sine over cosine. Cotangent theta is cosine over sine. And I'm sure you can see what's going to happen already, but I'll write it out. And cotangent is cosine over sine theta, and of course they cancel everything out, so that equals 1. Now, keeping in mind I'm trying to get to this, and I don't know if you remember with the simplifying video, but anytime you have two pieces to a problem, like the difference between two things, one is a fraction and one is not, find a common denominator and combine it into one problem. So I'm going to multiply this one by cosine squared over cosine squared, because that's going to be my common denominator between the two, right? So then I have 1 minus cosine squared theta over the common denominator of cosine squared theta. Still wanting to get to that. Well, now, lucky for me, my numerator matches perfectly. My denominator does not, but if I remind myself of the Pythagorean identity that says cosine, you can take a peek over here, right? Sine squared theta plus cosine squared theta equals 1. So I'm going to use that one right now. Alright, so again, I'm going to use sine squared theta plus cosine squared theta equals 1. So that means if I rearrange it, cosine squared theta equals 1 minus sine squared theta. So I'm going to replace the numerator, the denominator, which is cosine squared theta with 1 minus sine squared theta, and that is exactly what I wanted to get to. So I have just verified that the left-hand side equals the right-hand side. By the way, verify means that it is definitely a true statement. You're just showing that. So if you can't get it to equal out and you think, oh, you can't verify it, well, I guess you're wrong. So to verify something means, yes, it's true. You're just showing why. All right, I'm going to go through these a little bit quicker. Verifying still. So I'm going to work with the right-hand side, again, to get it to try to equal cosecant. So secant, you know, is 1 over cosine. Cotangent, you should be comfortable with, that's cosine over sine. And the cosines cancel out, right? So you have 1 over sine of x. We're trying to get to cosecant, and sure enough, 1 over sine of x equals cosecant. So that one wasn't too bad. Alright, then the next one says sine squared x plus over cosine plus cosine equals secant. So again, when you have the two fractions, you want to add them together to combine it to be 1. So that would be a wise first step. So I'm going to put this one over cosine x also, which means I have to multiply the numerator times the cosine x, so that will make it squared. So I just got my common denominator. That leaves me with sine squared x plus cosine squared x over my common denominator of cosine x, and I'm looking to get to secant of x. Pythagorean identity says sine squared plus cosine squared is 1, so that's nice. 1 over cosine of x, and sure enough, 1 over cosine is secant, and secant of x is what we wanted to get to. Alright, this last one to verify, I'm going to, again, work on the left-hand side. I'm going to distribute the cosine through, so I'm going to have cosine x times cosecant plus cosine x times tangent, and I'm trying to get to this, so keep that in mind. I didn't really leave a lot of room. So I'm going to change my non-cosine functions into cosines and sines. So I have cosine x times cosecant is really 1 over sine, and tangent is sine over cosine. So here nothing cancels out, but I can condense it anyway to cosine x over sine of x. And the plus this side, the cosines cancel out, so I have just plus sine of x. And I know that cosine over sine is cotangent, so that's cotangent x plus sine of x, and that's exactly what the right-hand side is supposed to equal. So I just verified it.